Our project focuses on better classification of social media toxicity through data augmentation. Internet toxicity has been a problem on social media platforms since their creation. Moderators of these platforms have a difficult responsibility to remove these toxic comments when they become profane, such as cursing or slurs, or are a risk to the safety and well-being of the users, such as direct threats. Our project seeks to simplify this responsibility by automating the process of identifying toxic and abusive comments. Our motivation for this project comes because moderators do have this difficult responsibility, and large social media platforms such as Reddit, Facebook, Twitter, and YouTube rely on their staff to moderate content, which is really detrimental to the mental health of the staff as they see some pretty heinous things. And with the large scale of growth comes more toxicity and the need for more manpower. And smaller communities, such as small Discord servers, can't spare this level of manpower.
So our NLP problem is basically transfer learning for an existing model, specifically BERT models. And we want to see how they handle new forms of textual abuse, such as can it handle comments from trolls? Can it handle comments that are sarcastic, abusive, racial slurs? And so basically, we'll be using multiple comments data sets, specifically two, and you'll see that in the next slide. And basically, we're going to be comparing the results with each other. Basically, given arbitrary Reddit comments, we want to compare our two models' performance at identifying positively labeled comments, our positively labeled comments or toxic comments, while our negatively labeled comments were non-toxic comments. So the two data sets we'll be using are the Reddit norm violations or RNV dataset and the push-shift IO Reddit comment archive. So the RNV dataset is comprised of only positive or toxic examples, and it makes up roughly half of our overall data. And this data was collected from the top 100 subreddits over a 10-month period from May 2016 to May 2017. And the push-shift.io Reddit comment archive is technically has no data cap because it continuously pulls data from Reddits. So basically, instead, what we do is that we use data from the same time period, specifically the first 3 months, and the same subreddits as the RNB data sets. And while some of the examples in this dataset could be deemed as toxic, deep learning models have been shown to be robust against mislabeling during training, and there are ways to identify this mislabeling. So therefore, we think it's fine to have all these data be classified as non-toxic or negatively labeled data.
For data collection, we collect the RNB dataset from GitHub and the compressed push-shift data from their website. After decompressing the data, we perform the same pre-processing as RNB dataset, and we also make sure that we collect the subreddits used in RNB, which gives us the final version of the push-shift data. After collecting this data, we use the examples from RNB as positive and the ones from push-shift as negative, and then we construct the first dataset, which is used to train a pre-trained BERT model. Although there might be some noisy levels in the push-shift data, we assume that this would not be a problem due to the robustness of deep learning against noisy levels. Now that we have our base model, we use this along with something called data augmentation on a different month of push-shift data to construct our second set of dataset. So the data augmentation considers that if a user has a certain number of comments and a certain percentage of his comments are classified as toxic by the base model, then all of his comments are considered to be toxic in the second dataset. This dataset is used to train the next pre-trained BERT model, which uses the same hyperparameter as the base model, and we call this model the adjacent model. Finally, we use both the models to classify a different set of push-shift data with the assumption that the adjacent model will perform better than the base model.
We didn't get a positive result overall, but we're going to go ahead and talk about what we did get and what can be done to improve it. At the top here, you can see where we ran a month worth of data through both classifiers and got these outcomes. The top left cell, you can see that both classifiers agreed that 102,000 comments were toxic. Bottom right, they both agreed that 5.5 million were non-toxic. The interesting categories here are that our base model identified another 102,000 as toxic, and our adjacent model identified 9.8 million that were toxic. So what's actually interesting is when you look in these two categories. We hand-coded 60 examples from both categories and looked at what they were. So interestingly, we found that 95% of them were false positives. So what this means is while our model is absolutely useless on its own, it could actually be used in conjunction with the base model to drastically reduce the false positive rate. Another interesting thing that came up when we were actually looking at the results is that toxicity itself is kind of hard to identify. We had very inconsistent hand coding. While we only had 5 examples where a majority of us agreed that it was toxic, there were another 16 that a single person thought were toxic. Part of that was that we didn't actually establish a functional definition to start with, but it is a hard problem that we're working on. Another very amusing thing in this is that both models decided that people who post about Pokemon are toxic users. I have no idea how to feel about that as someone who grew up with Pokemon. Part of our issue was that we made assumptions that weren't entirely true about the distribution of the original data. We had assumed that there were users who consistently posted a large number of toxic posts, and that ends up not entirely to be the case. What you can see down here on the left is the percentage of negative comments a user makes. On average, an average user makes 8.5% of their comments as toxic. But what you can see over here on the right is total comments by user on the bottom and the number of toxic comments on the top. And what you can glean from that is that what actually happens there is that 8.5% is very heavily biased by people who make 1 or 2 comments total, and they both happen to be negative. In order to fix this, we took out the people who only have 1 toxic comment, and what we ended up with is a distribution where we just got a bunch of people who post a ton of content, but still only have a couple negative ones. To fix both those issues, we ended up taking people who have 23% of their comments as toxic and at least 2 comments total. That gave us what we originally wanted our distribution to be. That distribution is still far from ideal, though. So continuing to work on the model, the simplest way to actually continue would be to, instead of using 1 month of data to calculate all of these things, is if you use the original 10 months, then each individual user will have a lot more comments, so it will be easier to select users from it that you want for the adjacency. Another way to extend the work would be to use some other form of adjacency. So in this case, we're thinking threads. If people are having an argument, then the parent and child comments of the toxic one may be toxic as well. And then finally, our data set is scraped after the fact, so there are a lot of comments that are deleted that we don't have access to. If you actually had access to those comments, which since they're deleted are fairly likely to be the toxic ones, we think you could have a much richer training set.